Dear students, in this lecture, we are going to derive one of the characteristics of TE and TM waves in rectangular waveguide, which is named as propagation constant. Let us recollect few formulas from the previous derivations. That is, we know that A square plus B square is equal to H square. And this formula we might have derived in the general wave equation for rectangular waveguide for both TE and TM waves. Now, we know A is equal to m pi by A and B is equal to n pi by B. And this H square can be written as gamma square plus omega square mu epsilon. Here, A is nothing but the width of the waveguide along x direction and B is width of the guide along y direction. Also, m and n are integers. Now with this base, let us derive the propagation constant for this TE and TM waves in rectangular waveguide. So we know that h square is equal to gamma square plus omega square into mu epsilon. And this h square can be written as, from this we can write h square as a square plus b square. Now, from this equation, gamma can be written as h square minus omega square mu epsilon in square root. Now, replace h square as a square plus b square. So, we'll get gamma as root of a square plus b square minus omega square mu epsilon. From this, we can write a as m pi by a, b as n pi by b. So, gamma becomes root of m pi by a the whole square plus n pi by b square minus omega square mu epsilon. This is the general expression for propagation constant. Now we are going to consider the different cases for this gamma. For small frequencies, this gamma will be real. This gamma will be equal to the attenuation constant alpha and it will be real. And when gamma is real, no wave will be propagating through this rectangular waveguide. There won't be any wave propagation, right? For small frequencies. Now, as frequency increases and reaches a particular value Fc, this gamma becomes 0. For small frequencies, there won't be any wave propagation and gamma is real. Whenever the frequency reaches Fc, which is the cutoff frequency, gamma becomes 0. And for all values of f greater than fc, when f is greater than fc, gamma becomes imaginary. That is, gamma becomes equal to j beta. And only after this fc frequency, wave propagation is going to take place. So we'll get different expressions for the same propagation constant gamma based on whether it is very small or it is equal to 0 or it is greater than the cutoff frequency fc. Now, let us take the case when f is equal to fc. F is equal to fc. Gamma, we said that gamma will be 0. It becomes 0. Now, when gamma becomes 0, we can write, see, h square is equal to gamma square plus omega square mu epsilon. Is it not? So, from this, when gamma becomes 0, when this gamma becomes 0, h square can be written as omega square mu epsilon. Now, since gamma is becoming 0 at f is equal to fc, this omega can be written as omega c square mu epsilon is equal to h square. Now, omega c square mu epsilon is equal to h square is nothing but a square plus b square, which is m pi by a the whole square plus n pi by b the whole square, right? So we can replace this h square as m pi by a the whole square plus n pi by b the whole square. Now omega c square can be written as, bring this mu epsilon to the other side. So it becomes 1 by mu epsilon into this value. If I write omega c, the right hand side becomes 1 by root of mu epsilon, root of m pi by a the whole square plus n pi by b the whole square. This is the expression for omega c. It can also be written in terms of fc. So fc is equal to, we know omega c is 2 pi fc. So fc becomes 1 by 2 pi root of mu epsilon, root of m pi by a the whole square plus n pi by b the whole square. Now this is the value of cutoff frequency, and this occurs when gamma becomes equal to 0 at f is equal to fc. The frequency fc below which there is no wave propagation, or you can say the frequency above which the wave propagation exists, is called as the cutoff frequency. So here we can define a cutoff frequency as fc. Now below this cutoff frequency, there won't be any wave propagation. And above all these cutoff frequency values, you will have wave propagation. Now this frequency above which wave propagation occurs is called as cutoff frequency. Now the propagation constant can be written as gamma is equal to root of h square minus omega square mu epsilon. We can bring this h square outside the square root, so it becomes h root of 1 minus omega square mu epsilon divided by h square. Now this h square becomes equal to omega c square mu epsilon when gamma becomes equal to 0 at f is equal to fc, right? So we can replace the h square in the denominator by omega c square mu epsilon. Is it clear? And this can be written as, this omega mu epsilon will be getting cancelled. In terms of f, you can write this as h into root of 1 minus f by fc the whole square. And h can be written as omega into root of mu epsilon into 1 minus f by fc the whole square. So this is the value for gamma at f is equal to fc. Next, let us see the same value for gamma when f by fc the whole square is less than 1. That is, when the frequency f is less than the cutoff frequency fc. Now, when f is less than fc, from this we can say there won't be any wave propagation. As we told earlier, when for small frequencies, that is when f is less than fc, gamma becomes equal to alpha and it will be real. When f is equal to fc, gamma will be equal to 0. When f becomes greater than fc, gamma will be purely imaginary and wave propagation takes place. So now we are going to consider the second case. We have completed the case of this at f is equal to fc, gamma is equal to 0. And we have determined the value of attenuation constant for it, propagation constant gamma for it. Let us take the second case when f becomes less than fc. Now gamma becomes equal to alpha. Gamma will be real and it becomes equal to alpha. And gamma can be written as h into root of 1 minus f by fc the whole square. Bringing this h square inside, as usual, the expression for gamma is going to be root of h square minus omega square mu into epsilon. The third case is when f becomes greater than fc. As we know, when f becomes greater than fc, gamma is going to be imaginary and its value is going to be j beta. Alpha will be 0 in this case. Here alpha is 0. So, from the general expression for gamma, which is root of h square minus omega square mu epsilon, we can write gamma as root of taking negative sign outside, omega square mu epsilon minus h square. Now this minus sign can be considered as j square inside the square root. So instead of this minus, we can write j square and we can take this j outside the square root. J square outside the square root, it becomes j. So the value will be root of omega square mu epsilon minus h square. As usual, replace h square as a square plus b square. Now, a square is nothing but m pi by a the whole square. B square is nothing but n pi by b the whole square. We are replacing it. This side we have gamma, which is purely imaginary and it's equal to j beta. This is equal to this value. Now this j and this j can be cancelled and the value of beta can be written as root of omega square mu epsilon minus m pi by a the whole square minus n pi by b the whole square. The same value for beta can also be expressed in a different way. That is, gamma is j into beta, j into root of gamma value is root of h square minus omega square mu epsilon. If I take minus sign outside and replace it with j square and take this j outside the square root, we can write gamma in this form, right? Now, h square can be written as omega c square mu epsilon. H square is equal to omega c square mu epsilon. So if we replace h square is equal to omega c square mu epsilon, here, if I take this omega square mu epsilon as common, we can write gamma as j root of omega square mu epsilon into 1 minus omega c square mu epsilon divided by omega square mu epsilon. We can write this as j. If I take this omega square mu epsilon outside the square root, it becomes omega root of mu epsilon into square root of 1 minus omega c square divided by omega square. Mu epsilon gets cancelled. This is equal to gamma, which is nothing but j beta. So here j again can be cancelled and I can write beta as omega root mu epsilon root of 1 minus fc by f the whole square. So in this way also we can express the value for beta. Is it clear? So in this lecture, we have derived the propagation constant for TE and TM waves in a rectangular waveguide for 3 different cases. The first case is when f is less than fc, gamma will be real and it will be equal to alpha. When f is equal to 0, gamma becomes 0. And when f becomes greater than fc, wave propagation occurs. And in this case, gamma will be purely imaginary. And it is given by j beta. The value for beta is this. Thank you.